7.3 goes over adding, subtracting, and multiplying radicals. The first part of your lesson goes over adding and subtracting these radicals. It tells you that the square root of 2 is approximately 1.414, and the square root of 3 is approximately 1.732. We are not going to be using a calculator for these, so when you are doing these types of problems, you are going to leak them in radical form. So this whole part that tells you what these square roots of these terms mean are pretty much pointless. Like I said, we're not going to be using those. We're going to be keeping it in radical form. So the important part about these adding and subtracting these radicals is that you can only add or subtract the like radicals. In other words, the index, the little number that's attached to the radical sign, and the number underneath the radical in simplest form needs to be the same in order to combine it with this another radical that has the same index and the same number underneath. When that happens, you keep the index and the number underneath the radical with the radical symbol, and you just add or subtract the terms in front. So if we look at the one that they give us, the square root of 2 plus the square root of 5, and I'm looking right here, those square roots of 2 are the same for both of these. So it's similar to saying 3x plus 5x is equal to what? You're going to keep the radical of that square root of 2 and just add the terms in front of it. So 3 plus 5 gives us 8, so 8 square root of 2 would be our answer. For example 1, it just tells us to simplify the following expressions. Assume all variables represent positive numbers. We're going to keep these also in radical form. If we look at example A, we have 3 square root 5 plus 4 square root 5. The square root of 5 is the same on both, so we're just going to represent this as 3 plus 4, keep the square root of 5. 3 plus 4 is 7. We keep the square root of 5. 7 square root 5 is our answer. For example B, we have the fourth root of w minus 6 fourth root w. So once again, our fourth root w is the same exact thing, same radical, same index. That fourth root of w is like saying 1 times the fourth root of w. So we're really doing 1 minus 6, keeping the fourth root of w. 1 minus 6 is negative 5, keep the fourth root of w. You have negative 5 fourth root w as your answer. For example C, we have the square root of 3 plus the square root of 5 minus 4 square root 3 plus 6 square root 5. For this one, your like terms here are the square root of 3 with the negative 4 square root 3, as well as the square root of 5 with the 6 square root 5. So we're going to combine the 1 square root 3 minus 4 square root 3, and then we're also going to combine the square root of 5 plus 6 square root 5. The 1 minus 4 gives us negative 3 square root 3. We're going to put a 1 in front of that square root of 5 that doesn't have a coefficient, so to say, to it. And we're going to do 1 plus 7, 1 plus 6, which is 7 square root 5. So we just have negative 3 square root 3 plus 7 square root 5. For example D, we have 3 cube root 6x plus 2 cube root x plus plus the cube root of 6x plus the cube root of x. Now, yes, your indexes are all the same for these 4 radicals. However, what's underneath is not. So you can only combine the ones that have the same index and the same term or terms underneath the radical. So with this one, your 3 cube root 6x and that cube root of 6x are like terms. The 2 cube root x and just the cube root x are like terms. So I'm just going to rewrite this and say we're doing 3 cube root 6x plus 1 cube root 6x. And then we're going to have 2 cube root x plus plus the cube root x. So the 3 plus 1 give us 4 cube root 6x, and the 2 plus 1 gives us 3 cube root x. for the next part of our lesson. We're doing the same exact thing, except now we have to simplify these radicals before we can combine them. If we look at example 2a, we have the square root of 8 plus the square root of 18. That square root of 8 can be simplified because 8 is 2 and 4, 4 is 2 and 2. And when we do square roots, we group up sets of 2. So this is the same thing as saying 2 square root 2. That 18 is 2 times 9, and 9 is 3 times 3. Those 3's pair up, so we're going to have 3 square root 2. Now we see that both of these have the square root of 2 attached to them, so we can combine their terms that are in front. So 2 plus 3 gives us 5. Keep the square root of 2. 5 square root 2 is your answer. For example B, we have the square root of 2x cubed minus the square root of 4x squared plus 5 square root 18x cubed. We're going to simplify each of these. That square root of 2x cubed, that x cubed, again, divide the 3 by 2, you get 1 with a remainder of 1. So one of those x's is going to come out, and you're going to have the square root of 2x left over. That negative square root 4x squared is the same thing as 2x, because the square root of 4 is 2, and the square root of x squared is x. Then we have that 5 square root 18x cubed. Well, one of those x's is going to come out, and one of them stays underneath. The 18 is 3 and 6. 6 is 3 and 2. So just like the problem before this, the 3 pairs up. We're going to bring it out. So we're going to do 5 times 3x square root 2x. When you multiply these, because the 5 was out front beforehand, the 3 and the 5 will multiply, or the 3 and the 5, or the 5 and the 3x will multiply, and it just stays attached to that 2x. So we're going to have x, or 1x, square root 2x, minus 2x, plus 15x, square root 2x. Your like terms here are the ones that have the same radical attached to them. So that's the 1x and the 15x. We add those, and we get 16 square root 2x minus 2x. So just because that 2x, that negative 2x on the outside, or the after the 16 square root 2x, because it doesn't have the radical over it, you cannot combine it with the 16 square root 2x. Just because they're the same term, and as one that's a whole number or a whole number term and one that's a radical term, they're not like terms. So you cannot combine these. You got to leave it just like you see it here. For example C, we have the cube root of 16x to the 4th power y cubed minus the cube root of 54x to the 4th power y cubed. So again, we're going to simplify these first before we can do any adding or subtracting. For the cube root of 16x to the 4th y cubed, that 16 is 4 times 4. 4 is 2 times 2. We're looking for a group of 3, so those 3 2's pair up. That leaves us 2 with 1 underneath. The x to the 4th power, divide that by 3. You get 1 with a remainder 1, so that x stays underneath. And that y cubed, divide the 3 by 3. You get just y, or 1, so the y comes out. So you're going to have 2xy cube root 2x left from the cube root of 16x to the 4th y cubed. For the negative cube root 54x to the 4th y cubed, 54 is 6 times 9, 6 is 2 and 3, 9 is 3 and 3. So we have the 3 3's that pair up, they're going to come out. That x squared, the cube root of x to the 4th is x cube root x. And then the cube root of y cubed is just y. So that leaves us with 3xy cube root 2x. Now, you see here that they both have the same radical attached to them. So combine what's in front. You're going to do 2xy minus 3xy cube root 2x. Now, these two terms that are in parentheses that I put in front of the cube root of 2x, you can combine because they are like terms. They have the same variable terms attached to them. So 2 minus 3 is negative 1. We can just write that as negative xy cube root 2x. For our next part of our lesson, we're going to be multiplying these radicals. When you multiply radicals, as long as your index is the same, you can multiply what's underneath the radical. So if you look here, we have the square root of 5 times the square root of 3. Your index is the same because they're both the square root, so you'd multiply what's underneath them to be the square root of 15. For the cube root of 2 times the cube root of 5, again, your index is the same, so 2 times 5 gives us 10. That's the cube root of 10. For your next one, you have the fifth root of x squared times the fifth root of x. Again, your root is the same. They both have indexes of 5, so that's just going to be the fifth root of x cubed. For example 3, we're just multiplying and simplifying these. For example A, we have 5 square root 6 times 4 square root 3. So the terms in front will multiply together, as well as the terms inside will multiply together, again, as long as your index is the same. So we're going to do 5 times 4 on the outside, and the square root of 6 times 3 on the inside. Now, if it was me, I wouldn't multiply the 6 and the 3 together because my factors of 6 are 2 and 3. So I know that these two 3's are going to pair up, and that 3 is going to come out, and the 2 is going to be left over. So in reality, I'm doing 20 times 3 square root 2. The 20 times the 3 gives us 60. We keep the square root of 2 attached to it, so it's just 60 square root 2. For example B, we have the square root of 3a squared times 6a. The square root of 6a. So with this one, I'm just going to rewrite it to be 3 times 6 times a squared times a, since it's all underneath the radical with the same index. That 6 is 2 times 3, so I'm going to rewrite this one more time. That a squared is also a times a. So again, I'm going to rewrite this as 3 times 3 times 2 times a times a times a. My index is an invisible 2, so I'm looking for pairs or groups of 2 to pull one out. The 3 comes out, the a comes out. We're still left with the square root of 2a. So that's 3a square root 2a. Now, if you realize example B is similar to example A in the fact that you're still working with the 3 and the 6 underneath the radical. With this, I just did it 2 different ways. It's totally up to you which way you do it. With example B, it just expands it a little bit more, so that way you see the terms that pair up with one another. For example C, we have the cube root of 4 times the cube root of 4. So again, with this one, our index is the same, so we can multiply what's underneath. This would just give us the cube root of 4 times 4, which again, you can separate the 4's to be 2 times 2. You're looking for a group of 3 2's to pull one out, so it's going to be 2 cube root 2. For example D, we have the fourth root of x cubed over 2 times the fourth root of x squared over 8. So I'm going to rewrite this just as the fourth root of x cubed over the fourth root of 2 times the fourth root of x squared over the fourth root of 8. Now, when we multiply these, we're multiplying straight across. So we're going to have the fourth root of x cubed times x squared all over the fourth root of 2 times 8. Now, if you wanted to separate these terms, this would give you the fourth root of x times x times x times x times x over the fourth root. That 8 is 2 times 4, 4 is 2 times 2. So 2 times 2 times 2 times 2. Your index is 4 on both of these, so you're looking at groups of 4. You have 4 x's on the top, so that one comes out. The one that's left over stays underneath the radical. On the bottom, you need 4 2's in order to pull 1 out. You have 4 2's, so you just have x 4th root x over 2. Example 4 tells us just to multiply and simplify. When we multiply here, we want to see if what's on the inside of our parentheses can be simplified before we do anything. If we look at example 4a, we have 3 square root 2 times 4 square root 2 minus the square root of 3. On the inside, you cannot simplify any of that, so we are just going to distribute in this 3 square root 2. So we're doing 3 square root 2 times 4 square root 2, and I'm going to keep the sign with that 3 square root 2 times the square root 3. So when we do these, the 3 and the 4 are going to multiply to give us 12. Underneath, we have 2 times 2. And then with that 3 square root 2 times the square root of 3, we're going to have a negative 3 square root 2 times 3. With the first radical, that 2 times 2 underneath, you have a pair of 2's, so that they're going to pull out. So it's going to be 12 times 2. And then the 2 times 3 underneath the second radical is just going to give us negative 3 square root 6. The 12 times 2 is 24. So 24 minus 3 square root 6 is our answer. For example B, we have the cube root of a times the cube root of a minus the cube root of a squared. Underneath that, inside the parentheses, you cannot simplify anything. So do what you did before this question and distribute the cube root of 3. So we're going to do the cube root of a. The cube root of a times the cube root of a minus the cube root of a times the cube root of a squared. We said prior to this that if our index is the same, we just multiply what's underneath the radicals together. So we're going to have the cube root of a squared minus the cube root of a times a squared, which is a cubed. When your index and your power are the same, they cancel each other out. So this is just the cube root of a squared minus a. For example C, we have 2 square root 3 plus the square root of 5 times 3 square root 3 minus 2 square root 5. So with this one, we are going to FOIL. So we're going to do the 2 square root 3 into the second set of parentheses. Then we're going to do the square root of 5 into the second set of parentheses. So we're going to do 2 square root 3 times 3 square root 3. Then that 2 square root 3 is positive, so we're going to multiply it then by a negative 2 square root 5. Then we have the square root of 5 times the 3 square root 3 and the square root of 5 times a negative 2 square root 5. The 2 square root 3 times 3 square root 3, the 2 times the 3 multiply, we get 6. The 3 times the 3 underneath the radical, we are also going to have. Then we have 2 square root 3 times negative 2 square root 5. So the 2 times negative 2 is negative 4. Underneath the radical, 3 times 5. Next we have the square root of 5 times 3 square root 3. So that 3 is going to stay outside. Underneath we're going to have 3 times 5. Next we have the square root of 5 times negative 2 square root 5. So that negative 2 is going to go out front. And underneath you're going to have the 5 times 5. Simplify this. For the 6 square root 3 times 3, you have a pair, so that becomes 6 times 3. For the negative 4 times the square root of 3 times 5, that simplifies to be negative 4 square root 15. For the 3 square root 3 times 5, that's a positive 3 square root 15. And for the negative 2 square root 5 times 5, you have a pair of 5, so that's negative 2 times 25. Negative 2 times 5. You just keep the 5. So from here, you're going to multiply and combine like terms. Your like terms here are this negative 4 square root 15 and that 3 square root 15. So the 6 times 3 is 18 minus the square root of 15, because negative 4 plus 3 is negative 1. And then you have that negative 2 times 5, which is negative 10. Your 18 and your negative 10 are like terms, so we combine them and we get 8 minus the square root of 15. For example D, we have 3 plus the square root of x minus 9 all squared. We're going to use our rule for a binomial squared with the addition inside there. So we're going to have our first term, which is 3 squared, plus 2 times the first term, which is 3, times the second term, which is the square root of x minus 9, plus the square root of x minus 9 squared. All right, from here, you're going to have that 3 squared, which is 9. Oops. Then 2 times 3 gives us 6 times the square root of x minus 9. And then that square root of x minus 9 squared, that square root and that power have the same number for the index and the power, so they cancel out. So it's just going to be x minus 9. From here, you can get rid of those parentheses. So I'm going to just erase them. And then you can combine like terms. Your like terms here are those 9s, and they are opposites, so they cancel out. So we just have 6 square root x minus 9, plus x. Now what I like to do when I do my answers for these, anything that's not included in that radical term, I'm going to bring to the front so that way I don't get confused on whether or not that x is supposed to be underneath the radical or not. So I'm going to rewrite this just as x because it's positive. It's going to stay x. That 6 is positive, so I'm going to put a plus sign in front of it. So x plus 6 square root x minus 9. You could also put like a little line that goes down from your radical to indicate that's the end of that root or that radical as well. For our next set of examples, we're going to be looking at conjugates. Conjugates are literally the opposite sign in the middle of two terms within a binomial. So when we are looking at the conjugates, we realize that our radicals will cancel out. If we look at example 5, we're just finding the product. So for example A, we have 2 plus 3 square root 5 times 2 minus 3 square root 5. These two sets of parentheses are conjugates of one another. So the conjugate of 2 plus 3 square root 5 is 2 minus 3 square root 5. The reason why they're called conjugates is because, again, they are going to have the opposite sign in between the two terms that are there, and it will cancel out the radicals within your expression. So if we multiply these, we can realize that it's a difference of squares, or we can just FOIL it out. I realize that this is a difference of squares because they are conjugates, so I'm going to take the first term that's the same in both parentheses, which is 2, and I square it. I have my minus sign in between the two, and then I have my second term, which is 3 square root 5, and I'm going to square that. The 2 squared is 4. The 3 square root 5 squared. The 3 gets squared, the square root of 5 gets squared. So you're going to have 9 times 5. 9 times 5 gives us 49, so that's 45. So that's 4 minus 45, which just gives us 41. So this should actually be negative 41, not just positive 41. So with our next one, for example, B, we have the square root of 3 minus the square root of 2 times the square root of 3 plus the square root of 2. Again, we have a difference of squares here, so we are going to take the square root of 3 and square it minus the square root of 2 squared. The square root of 3 squared is just 3. The square root of 2 squared is just 2. And 3 minus 2 gives us 1. For example C, we have the square root of 2x minus the square root of y times the square root of 2x plus the square root of y. Again, we're going to take that first term, which is 2x, and square it, put subtraction between the two, then take that last term, which is the square root of y, and square it. From here, the 2 as your power cancels out the radical on the 2x, so it's just 2x. And then you have the power of 2 canceling out the radical on the y, so it's just y. So 2x minus y is our answer for this one. For the next part of our lesson, we are going to be multiplying radicals with different identities. So with these, just easier to look at the example, it tells us to write each product as a single radical expression. When we do these, we're going to be given these expressions in radical form, and we're going to turn them into exponential form since we won't be able to simplify those radicals. From there, we'll work with our operations and simplify them. For example A, we have the cube root of 2 times the fourth root of 2. The cube root of 2 is the same thing as saying 2 to the power of 1/3 times the fourth root of 2 is the same thing as saying 2 to the power of 1/4. Remember, the index is your denominator. The power on the term is your numerator. From here, we have the same base and we're multiplying, so we're going to keep the base and add your powers. That 1/3 plus 1/4 you cannot do. You need like denominators in order to add your fractions. So your least common denominator here is 12. You'd multiply the top and the bottom of the first fraction by 4, top and bottom of the second fraction by 3. So in reality, we're going to have 2 to the power of 4 over 12 plus 3 over 12. This simplifies to give us 2 to the power of 7 over 12. This is asking to write each product as a single radical expression, so our answer has to be in radical form. That 12 is your index, the 7 is your power, so we're going to have the 12th root of 2 to the 7th power. Like you listen to me do, you have to make sure you're paying attention to your directions. If it tells you to put it in radical form, or write it as a single radical expression, it should be in radical form. If it's not, then it'll tell you to put it in exponential form. But your directions will tell you either way what form your answer should be in. For example B, we have the cube root of 2 times the square root of 3. Now with both of these, you cannot simplify it any further. The reason why is because if you turned them into exponential form, you have 2 to the power of 1/3, because it's a cube root. So 2 to the 1/3 power times 3 to the power of 1/2. These do not have the same bases, so you cannot keep the base and add the powers. You cannot do anything with it, so that cube root of 2 times the square root of 3 is your answer.